Okay. Are you able to see my screen?
Yes.
Yes.
Thank you.
Yes, sir.
Thank you very much. Now, what we're going to do is we're going to inshallah try and finish this lecture. It's almost there. It's just maybe a couple of more slides supposed to be completed. So for the last 2 lectures, we have been focusing on the concept of package design. And we have understood that, when we are trying to design packages, we have to focus on the or packages to make packages more cohesive, and we have to somehow make sure that there are minimal coupling between packages. And for cohesiveness, we had a look at 3 different principles: the common closure principle, which was all about package should contain classes which are going to be changed together. We look at the CRP principle, which was all about packages should contain classes which are going to be reused together, and the third one was the reuse release equivalence principle, which is all about packages who are going to be released together should be put, the classes who will be released together for reuse should be put together. And for the coupling, we were looking at these 3 ones. We had a look at the first 2 one, which was the asynchronous principle. We said that there should not be cycles between the connections or the relationships between packages, and we should try our best to follow the stable dependency principle, which is all about creating the stability calculation for each package, and making sure that a package depends on a package which has a higher stability than itself. Of course, just to recall, stability in our context is all about how hard or easy it is for us to change. And we'll inshallah now going to look at the stable abstraction principle, which is the last principle for this coupling. But before that, I think we stopped somewhere here for the example. Before I show and discuss the example, any questions, guys? Okay.
Maybe not, sir.
Okay, that's good. So,
Doctor,
yes, please go ahead.
An hierarchical dependencies. I just calculate. Let me call the sans package, or even their sans, or their these dependencies.
Okay, let me answer it this way. What we will be doing is we will be calculating the stability value of each one of the package. Right. So for each individual package, we will calculate the value of S. And we know the formula, it's CA divided by CA plus CE, right? So basically we will just calculate these values for each individual package. And the rule says that, and it's actually good one, Omar, here, because this is exactly what I was about to talk about, is that you calculate packages for stability for each package, and then so you have a value here now, right? So let's say your value of S is X and this is Y. You have to organize them in such a way that a package should depend on a package which has a higher S value. So in this case, for example, and this is a hypothetical case here, is that, for example, I have a stable package. So for example, this means that the value of X, for example, or value of S in this case, for example, is say 0.9. And the value of S for this package is, for example, say 0.01, for example. Right. So the rule says that, it should be the other way around. A package should depend on a package whose S value is higher. So hence we are saying that in this example, we are violating this stability dependency principle. All right. Is this clear?
Yes.
Okay. Now, since we are violating this, we need to, before we even think about what is the solution for overcoming such problems, we need to understand what is the cause of this problem. What is really going to happen? What's the real cause of this violation? And actually, uh, as we discussed the other day, see, the packages at the end of the day consist of classes, and they have these dependency relationships between packages because the classes within them have that those relationships, and hence they are being reflected at the package level. So when you have a problem like this, where you are you have a package of high stability depending on a package of less stability, usually this could be there because of the classes which are inside them, and because of their relationships this is. So we always have to look at the cause of this problem, and of course the cause will drill down to the classes and their relationships. So there could be many solutions here, to be honest. It's just a very hypothetical example here, just to help us think and visualize, what is this. You can have a problem like this, and then what could be the reason for this, and solution could be, one can argue that why not we move C class to this one, or U class here, uh, or sometimes if you can't do that for other reasons, because for example for the cohesion reasons and so on and so forth, a magic solution is you create an interface. So basically what happens here is that you take it out, create a new split it out, create a new package which consists of the interface class, which gonna, for example, implement a certain so the implementation is taken out, is masked, and hence you break that dependency. And of course you will create an S value for this, you will create an S value for this, you will create an S value for this, or calculate an S value for these ones, and then of course you can organize them in any way, which satisfies this stability dependency principle. So far so good.
Sure, doctor, but this value for interface will be less than its value for U.
Oh, in this case, no. See, the thing is, you break this dependency, right? So then you have, of course, this is just a very narrowed down, zoomed in, part of this whole package diagram. Of course, there are so many other packages out there, and you will have to adjust it accordingly. Now, another very important point to understand here is, again, which is, I think, which you guys will surely face in your project, and I'll talk about the project inshallah very shortly, is that, see, if you're just going to apply the stability dependency principle, you might come up with the structure of a class of the packages which might not be logical. That's quite possible, right? So we have to take it with a pinch of salt here, and we have to understand that this is just a principle which is helping us, guiding us to achieve a certain target. And then to achieve this target, we might have to readjust our packages. We might have to break them into smaller packages, so on and so forth. All right, because we still, at the end of the day, want them to be more. We still want them to make sense from a context perspective. Now, this leads us to the last principle, which is the stable abstraction principle. It's a very simple principle, and it's just an extension of the previous one. It says that the stable packages, of course, we know what stable packages are. They are the ones which are hard to change, should be abstract packages, which means they should have abstract classes in them. In other words, a stable packet ideally should only be abstract, right? So that because abstract, when you have abstract classes, basically you're not changing them. They are very stable. You know they are hard to change. You don't want to change them. While the concrete classes or part of the code can be moved to your unstable packages. Uh, And basically how we really calculate this abstraction, stable abstraction, is a very simple formula, which is we basically just take a ratio of we take a ratio of the abstract classes in a package to the total number of classes in a package. And of course, again, the range, as was the case for the stability, the range will be between 0 and 1. And 0 will imply what? It will imply that a package has no abstract class at all, while a value of 1 will imply that your package contains nothing but abstract classes. So ideally, what you're looking for is that you're trying to come up with packages where the packages which are more stable should have higher abstractness value, which means they should have more abstract classes in it as compared to the packages who are unstable. And of course, the maximum value you can have is one that basically package, as I say, it says here, a package has nothing but only abstract classes. And the minimum value could be 0. And of course, you're looking for a case where you have a stable package, and you try to make sure that if you have abstract classes in your system, these abstract classes should go to your stable packages, and the structure should be organized in such a way that uh, that you have abstract classes. Packages are in an abstract class which are more stable than you have other packages which are unstable and have concrete classes in it. So is this point clear? Is this concept clear? Is this principle clear? It's just an extension of the previous one.
Yes, I think
Okay,
yes. Yeah.
yes, perfect. So let's summarize this. This is something we were supposed to complete the other day. So let's summarize this whole package design principle. The whole package design principle is that, and let's start with the coupling because we were talking about it, that at the end of the day, we want to have somehow minimize the coupling between packages. And the way we can achieve it is, first of all, let's avoid cycles, remove cycles or cyclic dependencies, organize them in such a way that by calculating the S value of each individual package, and organize them in such a way that a package depends on another package which is more stable than itself. And to help you achieve this, you can also follow the stable abstraction principle, which says that these packages which are more stable should have more abstract classes in them. And by applying these three rules, or these three rules or these three principles will help you achieve a target for your package coupling. And similarly, on the other hand, you want your packages to be cohesive as well. So you can apply these three principles. Like, for example, as we said in the beginning, maybe in the start of the project, maybe you will just follow the common closure principle, and you will basically group the classes together which are changing together. And I think as the system becomes more stable, you can refactor them and apply or follow the common reuse principle, where you're putting the classes together in a package which are going to be reused together. And eventually you can always enhance your system in such a way that, or refactor your whole package in such a way that these classes which going to be released together for reuse going to be put together in one package. So using these 6 principles, a combination of them, you try to get your near optimal solution where you maximize your cohesiveness and minimize the coupling. Of course, ultimately you want to maximize your cohesiveness and minimize your coupling. Any questions on this now?
Doctor.
Yes, Abdul Majid, please go ahead.
In the stable abstraction principle, we calculate the ratio of abstract classes, right?
Correct.
Is it abstract classes? We mean by it as the classes that apply to the abstraction principle, or the classes that has abstract attribute, which is abstract class and Java.
Abstract class. We're talking about the number of abstract classes.
Is it good if you have like many abstract classes?
Okay. Now you might end up having many abstract classes in a complex system.
Okay.
Right. So you can have an abstract class for example, a certain hierarchy of your classes, right? And you can have another abstract class here for another set of hierarchy.
Right.
All right. And as we're gonna move on to design patterns, very shortly, you will see some cases there that you may have multiple abstract classes for a certain complex problem. So here we are saying that what to do with that. We were saying that put them in such a way. Of course, because it's a matrix, so we have to define the range, right? But ultimately, you are trying to make sure that put the abstract classes into as which is the principle actually. It says that uh, the stable packages should be abstract packages. In other words, they have a higher abstractness value.
So to make the package stable, we need to have many abstract classes, right?
Yes. So they go hand in hand in a sense.
Thank you.
You're welcome. Any other question, guys, before we close this one? Okay. So I'll take this opportunity. Victor. Yes, please go ahead. Yes,
sorry, I have a question about regarding the package diagram. We can show components inside it, right?
Inside the package?
Yeah.
When you say component, this is an important one now. When you say component, what exactly you're saying here? Are you talking about the architectural components?
No, what I mean by component is the classes. Like I combine the classes to be the package and show this class.
Yes. So this is the right description. You will have a package and it will have classes in it. The word, when we use the word component, because this is okay, we use the word component loosely. Since here in this context, when we're going to talk about component, usually we'll be referring to architectural components, which is like a subsystem, or it could be one or many of these packages.
Okay.
Okay, cool. It's clear, right?
So, yeah, thank you.
So at the end of this, just keep this in your mind. A package is a collection of classes. And a component, an architectural component, can be only one package or could be multiple packages. Okay. So this is more. Sorry, please.
Could you repeat the statement?
Yes.
Statement?
So let's look at from bottom to up now, right? So let's look from bottom to up. The smallest unit for your whole application is what? A class, right? So a package will consist of classes. And an architectural component or a subsystem will be collection of packages. Or if you want to look at from top to bottom, as we are following in our course, a component, an architectural component, will consist of multiple packages. And then the question is, what is a package? A package consists of multiple classes.
So, Doctor, I have a question. In our case, in the project, do you have to make two package diagrams? Or depending on the architectural style? when we apply.
Okay. Yeah, and I'm going to talk about this very shortly now. This is exactly what I'm going to talk about now. Shall we move to that part now then? The project?
Yes, it's clear. It's clear.
Okay,
yes.
perfect. Okay. So let me stop sharing this one and let's move on to the project. Now, did you guys notice that I changed or I should not be saying changed, I update some of the
Yes.
details for the project, right?
Yes.
So let me take this opportunity to explain it to the whole class what exactly is going to happen. So I kind of restructured it to make it more clear. And I'm going to use this opportunity now to basically, explain it to one go, and I'll hope we can take questions here and discuss and make sure everybody's on the same page. Are you able to see my my screen now?
Yes.
Yes, Doctor.
Okay, perfect. Now, of course, I'm not going to be talking about this. This is absolutely clear. You guys know what's happening here. Now, first of all, I like to highlight this. This is absolutely very, very important. We have, mashallah, a significant number of students and teams here. So make sure you follow this naming convention, please, and you've put your team number there. This was already there, by the way. I'm just highlighting it. And of course, since it's a multiple members in a team, and we want to make sure that in each submission, somewhere at the end of your submission, you kind of report that how many meetings were conducted and what tasks were performed and who did what. This was already there in the template. I'm just highlighted it again just to make sure that everybody, each group, kindly put this information towards the end of your report for each submission. Now, this is where some changes, restructures is taken place. Now, first of all, I have because we are kind of restructuring it, and I thought it will be fair that you have enough time to absorb the change and work on it and come up with the quality work, because that's the ultimate aim at the end of the day. So I have readjusted the due dates. The first one now is due on the 31st of October, and then the next one will be on the 21st of November. So this is a bit heavier submission. That's why it has a bit more time. And then, we'll have the last one, which will be the week 14 on the 5th of December, inshallah. Now, each section, by the way, these deadlines now are fixed deadlines, as I announced in the team and the Blackboard. Hard deadlines, we will not be changing them at all because we cannot afford to change them anymore. They have rippling effects on each other, and of course, we need to finish it before the semester. So they are absolutely hard deadlines. Kindly manage your work accordingly, plan accordingly. Each submission has a very clear guideline on which sections needs to be done from our template. So, for example, in the first one, you're supposed to do section 1, 2, 3. Specifically, you'll be supposed to do section 4, 5, 6, and eventually you'll be doing section 7, 8, 9, 10. Right? So, let's use this table and according to the subsections you need to fill. Of course, this document, this STD document, is going to be progressively developed. So that's why we're doing 1, 2, 3 here. The next submission, I'm expecting that you still have 1, 2, 3 plus 4, 5, 6, and eventually the last submission will have the whole document because it will already have 1, 2, 3, 4, 5, 6, and then it will have 7, 8, 9, 10. So by this time, inshallah, by the 5th of December, inshallah ta'ala, we will have the complete STD ready. Any questions on this? Deliverable table before I move on to the template itself.
Doctor, about
Yes.
the deliverable sections, like in the second phase, should I add it to the first phase and submit it, or just submit it separately?
Yes, as I said, 1, 2, 3 is there. First version of the document is ready. Submission phase 1. Now phase 2 will contain 1, 2, 3 plus 4, 5, 6.
Okay.
So we append to it. Because at the end of the day, we want to have an STD, complete STD for our project. Okay. So if you're comfortable with this, yes, Zed, please go ahead.
Doctor, do we need to write all information about our meeting and what we did in each meeting?
Last summary, only summary. some basic summary, and you can create a table like this, some basic information.
Okay.
Yeah, so some basic information. Like you guys had a meeting on Teams and how many meetings you had, and who's doing what. Some very basic information. So you can. This is where I'm leaving up to team. They can come up with their own any structure to report it. Okay. Shall I move to the template now?
Yes, please.
Okay.
Yes.
So I'm going to stop this from the sharing and let's move on to the template. Okay. Now, this is a template I use for my senior design projects all the time. So I thought this is a good opportunity for us to also have a look and follow it, and inshallah it will really benefit you guys when you're going to do your senior capstone project probably next semester or the next year, inshallah. So this is a standard template and it's based on IEEE and so on and so forth. So it's a very common industrial specific industrial standard template. It has stuff in it, I expect you to follow these standards, just title and all that kind of stuff. Now, in the first phase, we will be doing the section number 2, which is the system overview and the system architecture. In the introduction, again, it has certain subsections. I expect you to just go on and follow it. It's a very standard thing talking about the purpose of this document, the scope, and the description is already given here, which kind of explains what needs to be written there. Overall, how it's organized and any restrictions, constraints, so on and so forth. So this is very standard stuff, basic stuff, actually. We're going to have the system overview, and this is, again, probably you will be getting a lot of this information anyway from your SRS document. Again, the reason I'm forcing this for us to have is because this will make sure that the team goes through at least the use case diagram of the system, and they have a common understanding of what the system is doing, and of course the context diagram as well. Now, if the context diagram I think is there, but if it's not there, of course, based on the understanding of the SRS, you can create a context diagram. Again, most of the time you really don't have to do much here, basically reproduce that, but the aim is to make sure that we go through their SRS, basic fundamental information about SRS, because you need to have a clear understanding of their system. And here's the third one, which is the critical one for this phase. And this is where I have done a bit of restructuring. So if you notice here, I'm now saying that you will. I have removed the word deployment because I thought a lot of you guys were getting confused about this. So we're going to focus on system architecture. What we're going to do here is, first of all, in 3.1, we're going to select at least 3 possible architecture styles. These architectural styles could be the basic architectural styles we have studied, or it could be a combination of these basic styles. I'm giving you an opportunity to be creative here and think out of the box for their problem. So select 3 ones and draw a respective block diagram. In other words, I'm saying draw 3 architectural style diagrams. Now, again, the word I'm using block diagram here is because there is no such thing as UML architectural diagram, right? So you can create your architectural styles using Visio, any other drawing tool. Each component could be represented as a rectangle, and you draw lines between them to show the connectors and so on and so forth. So basically, don't be confused. There's no such thing as a block diagram and such with architecture. It's just there to highlight that use any drawing tool to draw your structure, your architectural style. Okay, of course. So this means since you're supposed to select at least 3 architectural styles, so basically I'm expecting 3 diagrams, and for each one of them you have a bit of description about what are the components, what are the connectors, topology is the diagram itself, and what are the quality attributes. Again, this discussion needs to be specific application. This application, this SRS you're working on. So this should not be generic. When you say components, these components should coming from your application, right? For this specific application. And then in the section 3.2, which is a very critical section, basically I want you guys to go as a designers to go and evaluate these 3 ones, right? the ones you have selected, and discuss the rationale for selecting the architecture, the one you have selecting eventually. So because you drawn 3, eventually you will be selecting 1. So I want you to have a clear discussion on, what are the advantages and disadvantages or critical issues with these ones you have drawn in 3.1, and why are you going with this specific one. And eventually, in step number 3, you'll be drawing a package diagram. Again, I'm saying you can use the class diagram, which is already available in the SRS document on page 85. And, then you can draw a package diagram, again, using the principles we just studied. So you apply the coupling and cohesion principles on the class diagram, which is available on page 85, and come up with a package diagram, which, of course, maximizes cohesion, minimizes coupling. You apply the different appropriate principles accordingly. Just to highlight here, I'm pretty sure everybody is able to go and access the class diagram on page 85. If you're not, sometimes I notice that when you open the Word document, because of the setting of the Word, and they have incorporated this group incorporated the image of the class diagram. So, you might feel that it's not there, but actually it's there. You all have to do is basically drag it. And then if you drag it out, it becomes quite readable and it's quite, understandable, the image itself. So this is supposed to be done in the first phase, section 1, 2, 3. Later on, we'll talk about 4, 5, 6, but I'll talk about later. We don't need to confuse this today. So basically, this is what's supposed to be there. Now, of course, the floor is open for any questions on this. Yes, Saud, go ahead, please.
In section 1, we have introduction and we have constraints, overview, and so on. I'm thinking of writing something appropriate for section 1, 2, 3, and then when we add section 4, 5, 6, I update introduction.
Exactly. This is true.
Okay?
This is true. This is true. This is true. So now, since you talk about it, usually, especially when we do our 417, 418, usually we write section 1 towards the very end. But I thought maybe, because in that case, it usually makes sense because, you are the ones who are designing it. So basically, you know your system. Here, I'm kind of forcing you so that, at least you go through the SRS document and basically have some basic understanding.
So, we only derive the package diagram from the class diagram and the SRS document. That's the only. That's the only thing.
Yes.
So that's what I'm previously talking about, that if the one package diagram represent a one subsystem or one component of an architecture, how in our case would we apply it if we have one class diagram?
Yeah. Now, see, you will have one class diagram. So you basically, let's look from now top to bottom. So you have a class diagram. So you have a class. Sorry. So you have a class diagram here, right? Now you will use this class diagram to create packages. Now this is all together in one group here is because you by the time you're done with section 3.2, you already have selected one architectural design for your system, right? So you already know that, for example, you're going to be using an event driven architecture. And then I'm just using an example here. So you're saying event-driven application. So basically, you already know what are your potential components for this system. Now, if you're struggling to identify this, basically you can come up with a package diagram and then align them together as well. So this needs to be done in not in one iteration. Probably it will go through in 2, 3 iterations.
So regarding the styles. If we have a mixed style, do we consider it as one style or more than one?
Style. So one style.
The naming for the style would be as a
name. It would be see, the name is, you don't have to really give it a name. So because at the end of the day, this is your system architecture, right? So this is your specific system architecture.
Yes.
Right. So you don't have to give it a name as such. which is very common, by the way. You're talking about your architecture, basically, which you are using many basic simple architectures to come up with an architecture here.
I got it.
So it's a good point, actually. See, for you guys to come up with this, probably you will have to have some idea about your potential 3 architecture styles. And if I were you guys, I will go on and try to come up with a package diagram, because class diagram is already there. So I'll try to do this, and then I'll complement each other, and it will help me understand what are my components. Connector is going to be easy anyway, but it will help me understand what are my components.
Yes, that's clear.
Right. Cool. Alhamdulillah. Anything else, guys? I hope it's more clear now, and
Just a quick question for the purpose in the section 1, and I forgot the second one. Purpose and scope. We're writing for the purpose and scope of the project that they made, not. So it's like we're creating a second SRS document, but it's not.
Oh, no. This purpose needs to define the purpose of the STD only.
So what's? Because
it will be these will be like a paragraph, to be honest. These are like very small, tiny paragraphs, to be honest. They're just saying what exactly is going to happen in this design document, and who's going to read it.
Doctor, does the SDD, all the SDDs have the same purpose?
They all have the same purpose, but see, this is where the point is, and I think I need to emphasize this. As I said, these components gonna be specific for this system, the one you are working on, right?
Yes.
So this, and for example, you say client server, and you say I have a client, it's a component. No, that's not gonna fly. You need to tell exactly what is the component in this system. So is going to happen here. Yes, all the STDs will have the same purpose because it's a design document, but you need to spell it out that this is a design document for such system, and who's going to read it, because every system has its own stakeholders, right?
Oh, I got your point. Yes.
Yeah. So this needs to be specific. Everything needs to be specific for the system design I'm developing for.
But how to know that who would read it, because it's designed, then I think you wouldn't want the user to see it, right?
Yeah, fair enough. No problem.
So who is the other? Oh, I got your point. Sorry.
Yes.
Yes, I got your point.
Yes.
Doctor, I have a question.
Yes, go ahead.
If we are making an SDD document,
yes,
then we are using the waterfall process model, right?
In this project, yes.
So in our senior project, we will be forced to use waterfall.
If myself or Dr. Shaib are teaching, we go agile, or we call them semi-agile.
Okay.
Okay, so what we really do is in most of time when both of us are teaching, we have our own, we introduce agile in a sense that what we do is we do SRS because SRS needs to be done because we need to understand the project. But when it comes to design, we use design for 30% of the features of the application, and in 417 we go on and implement it and test it, and then we'll come back in 418 and take the same STD document and go for the second sprint and the third sprint. So actually we have 3 sprints.
Yes.
But this is specific to myself and Dr. Shaib.
Okay, thank you.
You're welcome. So all good, right?
Yes.
I think, inshallah, I think things are clearer. Yeah, shoot me a message, send me a message on Teams if you are still not sure. You still have some question, of course. But I believe my message is these discussions needs to be specific to the project. Okay.
Dr.
Yes, go ahead, please.
Sorry. So to make sure, is it okay to update the introduction every phase? It's okay, right?
So the sound was kind of lost in the middle. Can you repeat that?
Oh, sorry. It's okay to repeat the, to update the introduction every phase to make it appropriate for the content, right?
Absolutely, absolutely, absolutely. And I'm not forcing this, but when I teach 417, I force that, but I'm not forcing this here. But it's that because it's gonna be iteratively, so we kind of highlight that what has changed, right? But I'm not gonna really force that. But I expect that you guys update it.
Okay, thank you.
You're welcome. Okay, so we don't have much time, but anyway, because we are going into or we are moving into the the class diagram, and we're gonna move into the class design structures and the design patterns, and we'll be coming across a lot about the concept of interfaces and abstract classes, and we'll be using them again and again. I thought before we start talking about the actual design principles for the classes and design patterns, we should have a one more time, because though we discussed them, the interfaces and abstract classes earlier in this semester, but I thought maybe just to make sure that everybody understand them, some basic concepts, because we will be seeing them again and again, and we need to be absolutely clear about them. So I had a planned activity. Probably won't be able to finish it, but still we have 5 minutes at least. We can have a look at it, and we can try to do some of it. So let me share it. And are you able to see the screen now?
Yes, doctor.
Okay. So the for sure we'll not be able to finish it, but let's look at this now. Again, now another thing you will see now is that because we are moving into the classes and we are actually coming towards more detailed design now, you'll be seeing a lot of source code as well, and you will be seeing the relationship between classes and source code as well. So as it's kind of kind of evident in this activity as well. So I have an example abstract class in front of us now, right? And I like you guys to just comment on what are the key characteristics of an abstract class. Since we don't have much time, I ask you guys to maybe one by one, if you want to share your observation, what you believe are the key characteristics. So maybe let me drive the discussion here. For an abstract class, do you need abstract methods?
You can have them, but you don't need them.
So can I have an abstract class with no abstract methods?
No, what's the point then?
Variables, maybe.
You need
Yeah,
at
you
least
can,
one
I
abstract method.
think.
So you need at least one abstract method. So in this example we have, the deposit and withdraw, are they the abstract methods?
No.
No. What about so which one is the abstract method?
Calculate interest.
It's the calculate interest, yeah.
Calculate interest, right? So in an abstract class, you need to have at least one abstract method. And of course, the whole idea of abstract class is that you give them this this abstract method, and then the children can go on and and specifically give their own implementation. Now, if I have a children class is for this this bank. So for example, I have this bank in abstract class, and now I want to create a class for Riyadh Bank, for example, right? And Riyadh Bank now goes on and extends this bank. Do the Riyadh Bank class has to provide, or does the Riyadh Bank class has to provide an implementation for deposit and withdraw?
No.
No, everybody's comfortable with this?
Yes.
So what exactly Riyadh Bank class will have to do?
Just implement the calculate interest.
Exactly. They just need to go on and implement the calculate interest. So what if you don't provide the calculate interest in the Riyadh Bank class? What will happen? And you try to compile it.
Compile the same method?
Compile the Riyadh Bank class, which is extending the abstract class, and it does not has or doesn't have the calculate interest implementation in it.
I think it's gonna complain.
Yeah,
I'm
it's
not
gonna
sure.
complain. It's gonna throw it's gonna throw an error, right?
Yeah.
Now, can you create objects of abstract classes?
No.
No.
Oh.
No. All right. And of course,
But
this
you
is
can
the
make
base.
the type. You can make it as a type.
Yes.
True, but yes.
Mm.
So I think we'll look at the interface and a bit of discussion on this probably, inshallah, on Sunday now, right? It's already 10:50 now, so we'll stop it here, right? And then we'll look at, inshallah ta'ala, the the other concepts. And we'll move into the design concepts now, inshallah. So let me stop the recording, take the attendance, and then, of course, the floor is open for questions.